Hello guys, welcome back to another AIME problem solution video. Today we have yet another question here. As always, let's first start off by reading the question. So triangle ABC has sides AB equals 9, BC equals 5 square root 3, and AC equals 12. Points A equals PO, P1, P2, all the way to P2 2450, going to be equal to B, and are on segment AB with PK between PK minus 1 and PK plus 1. For K equals 1 to 2449. And points A equal Q0, Q1, Q2, all the way to Q 2450. For K 1, 2, and all the way to 2449. Furthermore, each segment from PK to QK, with K being between 1, 2, and all the way to 2449, is parallel to BC. The segments cut the triangle into 2,450 regions consisting of 2,449 trapezoids and one triangle. Each of the 2,450 regions have the same area. Find the number of segments PK to QK, with K being from 1 to 2,050 that have rational length. Now, let's first look at this graph that I've made for you. As you can see here, we have a bunch of lines here, although there's not a total number, as this graph is not to scale. However, it's a good example that we can look at. Now, as you can see here, if I were to be looking for, let's say, one of these trapezoids here, I'll color in black. This would be the area of the bigger triangle minus smaller triangle. So just keep that in mind. Now, because that is, we plot the smallest triangle, which is here. Now, this triangle, you can see that we can just keep on adding smaller trapezoids onto it to make it larger. And since each of these trapezoids and the triangle have the same area, we can write our first equation, which is that A, PK, QK. So this is the triangle. So for example, in this scenario, this triangle will be going from here to here to here to here. This is going to be equal to K over 2,450 times ABC. And this is because there's that one small triangle and K minus 1 trapezoids making up this bigger triangle. And since each of these have the same area, they add up to K, and it's a total of 2,450 of them. Now we'll move ABC here and make a ratio between their areas. So APK, QK on top, and ABC on the bottom. Now from here, we're going to find the ratio. We're going to find the ratio from QK and PK all the way to C, so from QK to PK to C to B. Now, because this is from one area to an area, and the next equation that we're writing, so I'll write it down here. Take a QK to BC. Since this one is from one area, since this one is comparing an area to another area, and these two are just comparing lengths, we're gonna have to square root this ratio to find it. So this is going to be equal to the ratio K over 2,450. And similar to over here, we're just going to move BC over, which means that PKQK, the line segment, is going to be equal to BC times square root K over 2,450. And now is a good time to realize that 2,450 is going to be equal to 2 times 5 squared times 7 squared. Now because we know that BC is going to be equal to 5 square root 3, as it says in the question up above, we can say that this is going to be equal to 5 square root 3, and then we're going to take out the 5 and 7 from 2,450, so times 1 over 5 times 7 times square root 7 of K over 2. Now, the 5 and the 7 here, the 5 and the 1 over 5 just cancel out here, so we don't have to look at them anymore. And this leaves us with 7 square root 3 times K over 2. Now, because these two are both square roots, we can just move this one into here, and then we receive 1 over 7, 3K over 2. Now what we're going to do is that we're going to be multiplying both halves of this fraction. So multiply 2 by 3, which is going to be equal to 6, and then we multiply 3k by 3, which is going to equal to 9k. But since 9k contains a 9, we then remove the 9 again and get a 3. So this is going to be equal to 3 over 7 times square root k over 6. And now we can solve for k. Now, because we need a rational length here, this is equal to pkqk, we need a rational length. This means that this part, so this part in total, should be an integer. Now, this means that k is going to have to equal to 6 n squared, where n is just going to be an integer. And this is going to have to be obviously be smaller than 2450. But why is this? Well, it's mainly just because that I said before, k only goes to 2450. So k equals 6n squared can't be bigger than it. Now this means that n squared is going to have to be equal to something between 0 and it has to be small. It has to be smaller than or equal to 20. This is because 20 squared is equal to 400, and 400 times 6 is 2400, which is slightly smaller than 50. And if you go over that, and we can't go over this number here. This means that n has to be a number from 1, 2, 3, 4, all the way up to 20. So that means k has 20 possibilities. So I write k equals 20 in a circle to show that there are 20 possibilities. So that means that since k has 20 possibilities, that means pk and qk also has 20 different possibilities. And so that means the answer to this problem should be 20. Thank you guys for listening. If you have any other way to solve the problem, please let me know down in the comments. And thank you guys for listening. Bye.